All right, so we're going to go ahead and continue our notes here. The next question says, if f of x equals x cubed minus 3x squared minus 46x minus 72, which of the following is not a factor? So we learned about polynomial division, and we talked about how if something divides nicely into a polynomial and there's no remainder, that means that whatever you divided in is in fact a factor of that polynomial. All right, so basically what we have to go do is we have to figure out which one of these factors gives us a remainder. And if it gives us a remainder, that means that it is not a factor of this polynomial here, okay? So yes, does that mean that we have to do division a lot here? Yes, we do. But fortunately, we can use synthetic here. If we look, all of these are just x plus or minus a number. So synthetic would be super duper easy here. So let's start out with this guy. All right, we're going to do 8. Remember, you switch the sign of this guy. You draw the little box, and then you take the coefficients on all of these. So the first guy is 1. The next guy is -3. The next guy is -46. And the next guy is -72. We're going to drag down the 1. We get 8 times 1. 8. We get a 5. 5 times 8 gives us 40. -46 plus 40 is going to give us a -6. And 8 times -6 gives us a negative, 48, right? So that gives us a remainder here, right? We could go through -72 minus 48. I don't know. What is that? Basically, it gives us a remainder of -120. So that means that this guy looks like it's probably our answer here, right? There is there is a remainder with him, so that means that it's not a factor. Now, because I want to make sure y'all know how to do this, let's go double check that all of these other guys are factors, okay? So that means we're going to go ahead, we're going to try 9 and make sure that we don't get a remainder. If we get a remainder, then we're in trouble. Because basically that means that we found the one guy that's not a factor, which is this guy here. So everything else, hypothetically, should divide nicely in. All right, so we do 9. We bring down the 1, 9, 6, 54. So we're going to do 54 minus 46, and I get 8. 8 times 9 is 72. So this means that x minus 9 is a factor. So this guy is good. All right, now we've got x plus 4. So we're going to do -4. 1, -3, -46, -72. We're going to keep doing synthetic here. We're going to drag down our 1, -4, -7. That gives us what? A positive, duh. Positive 28. I was looking at it like, this isn't going to cancel nicely. So now we've got a -46 plus 28, which gives us a -18. -18 times -4 gives us a 72. So again, we have a remainder of 0. That means that this guy here is a factor. Then let's try our last one. We've got a +2, so that means we got to do a -2 here. And we're going to do 1, -3, -46, -72. Drag the 1 down. -2, -5, positive 10, -36. We get 72. No remainder here. So what does this mean? That means that our original work here was correct, showing that this first guy is the one that is not a factor because he ended up with a remainder. All these other guys checked out and were shown to be factors because they divided nicely into the polynomial. All right, so our answer here would be x minus 8 because they wanted us to find the one that is not a factor. All right, so now it says they want us to find all of the zeros algebraically. So obviously we could go to Desmos, right, and graph this and see where this function goes through the x-axis. And that would give us at least all of the real zeros. However, they want us to do this algebraically. So what you can actually do is, since they told us this, if f of -8 equals 0, that means that this guy here is a factor, or I should say 8 is a 0, meaning that it's going to go through -8, 0. And therefore, x plus 8 is a factor, right? If it goes through -8, x plus 8 is a factor because it's always x minus the root, right? So you flip-flop the sign. So what we can do, since we know one of the roots, we can, again, go use synthetic. And again, if you want to do long division for this, you can, but it's going to take you a really long time. So I would highly recommend that you kind of just get really good at synthetic because it definitely saves you a ton of time. All right, so we're going to go ahead and do the division here. And this checks out, right? If they told us that f of negative 8 equals 0, that means that x plus 8 has to be a factor. Therefore, we should be able to divide this and not get any remainder, which is what happened. So the answer here, right, is x squared minus 3x plus 1. Okay, so what that means is that this guy times this guy would give us our starting polynomial. Now, to go on and continue to find the rest of the zeros, we need to take our remaining quadratic or our remaining polynomial and set it equal to 0 and solve. All right. Ooh, this should be a 2, not a 1. All right. So what you can do here is you're either going to have to factor or use quadratic formula here. Okay. So looking at this one is one that is factorable. We can do x minus 2, x minus 1, right? We got to figure out what multiplies to 2, adds to negative 3. That's going to be negative 2 and negative 1. You can set these equal to 0. Oops. You get x minus 2 equals 0, x minus 1 equals 0. We get x equals 2 and x equals 1. So if they want us to find all the zeros, obviously negative 8 is a 0. Now we found 2 and we found 1. So these would be all of our zeros of this polynomial. Now I want to show you on a graph what this looks like just so you kind of have an idea. Let's go to Desmos. And I could go ahead and graph this. And we get x cubed plus 5x minus 22x plus 16. And if we look at this graph, oh, what did I do wrong? Oh, I forgot the squared. Oopsies. There we go. All right. And if we look at this graph, obviously it's kind of ugly, but we can clearly see where it goes through the x-axis. It goes through at negative 8, it goes through at 1, and it goes through at 2. So that proves that we did this correctly, which is great. Unfortunately, really, checking it on Desmos is only going to work when all of the answers are real. When you have imaginary solutions, it's going to be a little bit more challenging to check on Desmos, but that's okay. All right, so let's keep rocking and rolling. In this case, they told us that x minus 9 is a factor. So if x minus 9 is a factor, that means that 9 is a 0. Okay? So what we could go ahead and do is we're going to, again, use synthetic division to divide 9 into there, and we should end up with a quadratic that does not have a remainder, that we can then either use quadratic formula or factor or do something with to continue to solve. So we get 3 minus 28, 7, and 18. We're going to drag down the 3, 27, negative 1, negative 9, negative 2, negative 18. We get no remainder. Great. So that means that our resulting quadratic here is going to be 3x squared minus x minus 2. And what we need to go do is we need to figure out where this quadratic is equal to 0 to find the rest of the zeros of the polynomial. Now, some of you guys will know this actually is factorable. Some of you guys know how to factor it. If you know how to factor it, more power to you. But I'm going to go ahead, since it has a leading coefficient, I'm going to go ahead and use quadratic formula. So you know that a is 3, b is negative 1, and c is negative 2. So we're going to do opposite of b plus or minus the square root of b squared, which negative 1 squared is positive 1, minus 4ac all over 2 times a. All right? And we can go to our calculator and plug this good stuff in. 1 minus 4 times 3 times negative 2. And we get a nice 25 in there. All right. Square root of 25 is 5, so we end up with 1 plus or minus 5 all over 6, which gives us 1 plus 5 over 6, which will give us 6 over 6, which is 1. 1 minus 5 all over 6, which is negative 4 over 6, which will give us negative 2/3. All right. So here, all of our zeros are going to be 9, 1, and negative 2/3. All right. Now, these, in fact, are all real zeros, so we could check this on Desmos. If I go and plug this polynomial in, we get, go away, please, 3x cubed minus 28x squared plus 7x plus 18. All right. And if we look, it does go through negative 2/3. That's the negative 0.6 repeating. It goes through 1, and it goes through 9. All right, last question here. So, again, they want us to find all of the zeros. So, if f of 4 equals 0, that means that it goes through 4, 0, meaning that x minus 4 has to be a factor. So we can go ahead, divide that into our polynomial using synthetic division. We bring down the 2, we get an 8, we get a negative 4, negative 16, and we get no remainder. So our resulting quadratic is going to be 2x squared minus 4x plus 4. All right. And of course, we got to try and figure out, where does this quadratic, where is it equal to 0? You could go ahead and try and factor this, but unfortunately, this one is actually not even factorable. We have to use quadratic formula on this one. So we're going to go ahead and do that. We've got a is 2, b is negative 4, and c is positive 4. So we're going to do opposite of b plus or minus the square root of b squared, which is 16, minus 4 times a times c, all over 2 times a. So I need to go to my handy-dandy calculator here, and I'm going to plug in what is inside of my radical here. And I get 16 minus 4 times 2 times 4. And I get a negative 16 in there. So I get 4 plus or minus the square root of negative 16 all over 4. So the square root of negative 16 is actually 4i. All right. Right, the square root of 16 is 4. Square root of negative 1 is I. 4i comes out. So we could actually go ahead. We've got 4 over 2 plus or minus 4i over 2, which gives us 2 plus or minus 2i. So those are our two solutions here. Again, notice how they are, in fact, complex conjugates of each other. So all of the zeros of this are going to be 4, and then 2 plus or minus 2i. All right? This is one way you could write the solutions, or the zeros. Another way you could write it is you could split this up into the two solutions that they are, right? You've got 2 plus 2i and 2 minus 2i. Those are both acceptable ways to write them.